So hurry. Se jodió todo now. All right, guys.
You talking about benches deodorant now?
No, it's not gonna happen.
That's
It's called arrogance and hubris, guys. You guys know that word? All right, so let's begin. So here's the problem. Here's number 12. By the way, last class I started doing this problem and I misinterpreted like what the things were, and I spent 15 minutes going in circles, and I realized after a kid shared with me the solution, I'm like, yo, what a mistake. So you got to read the question. So here, let's do the hedge. Here's the hedge. And you know what? I should do that in green. Let me do that in green. So let's do this in green. The hedge should be in green. Let's do it in green. So here's your hedge. Here's your hedge. This is the hedge. And now the fence all around it is here. And there we go. Now it says there, and let's zoom in on the question. It says one side of the rectangular sheep pen is formed by a hedge. The other three sides are available using fencing. That's the part in gray. The length of the rectangle is X meters. Now, when I read that last class, for some reason, because the previous question was about perimeter, I just said perimeter equals X, and that was my mistake. This is your length, X. Now, you could have also put X here, but then you can't show that part A is true. So let's begin with that. So if I call that X, what can I call the other sides? Yes, call it Y. Now, if that's true, how much? Oh, is he snoring? Yeah, he's snoring, man. He's sick, maybe. All right, so we add up everything there. If we add 2y plus an x, how much should we have? If we add 2y plus x, how much should we have? 120, correct. So I'm going to go ahead and say 2y plus an x equals 120. Does everybody realize why that's the case? Because how much fencing do we have? 120. Now, the first part, the question says, part A says, show that the area of the rectangle, that the area equals half x times 120 minus x. Show that's true. Okay? So, here's what you have to do. See, the area of that pen is x times y. And 2y plus x equals 120. So 2y equals 120 minus x. So y must equal 120 minus x over 2. So if you take this now and substitute it into here, you have that a equals x times 120 minus x over 2, which can be rewritten as half x times 120 minus x, and you're done. You've just shown that your area is half x times 120 minus x. All right, so where are you? Where are you at? Talk to me. Are you here? Oh, how do I get this here? You realize that all I did, so you see this part here? You see this part here? Yeah, just factor out the half. No, the x was here. The x was always here. Look, it was x times y. What did I replace? I replaced the y. The y is 120. So this here is y. 120 minus x times divided by 2. Yeah, and then I just factor out the half so that we can have the same answer that they wanted. They wanted essentially that they wanted you to show that half x times 120 minus x is the area. So not bad, right? It wasn't a bad problem. I've spent probably 15 minutes last class because I set up the problem with perimeter equals to X, and then that's my mistake right there. I said the perimeter is X, and I said that, and I used twice A plus twice B equals to X, and then I said that twice A plus B equals to 120, and tremendo redo I made just because I didn't interpret this correctly. So interpretation goes a long way. But obviously, I misread the problem. I'm trying to erase this. All right, so let's do the next question. And then I'll just pause the recording. We can go to lunch. I really don't want to eat during lunch. I want to go ahead and take a walk. I know, man. Because you spend like 10 minutes getting the food, and then like Taco Bell is not easy to eat while walking.
Yeah, it's, you know,
It's true, but. All right, guys, take a look at number 13. Number 13 is a deeper question. Go ahead. Yes? Oh, I'm not done. I'm not done. Okay, so let's do part B of number 12. Part B of number 12 says, calculate the maximum possible area of the sheep pen. So let's go ahead and do this. So do we have the area? Yes. So why don't you guys do that derivative? And then let me pause the recording so we're not wasting time. So I'm gonna pause the recording. So Sophia says that you're supposed to distribute, which is correct. Now if we had more rules for differentiation, we don't have to distribute, but let's go ahead and distribute. And then we're gonna be able to take the derivative of each term. So the derivative of A with respect to X is gonna be 60 minus X. We have a stationary point when dA dx is equal to 0. So 0 equals 60 minus X, so X must equal to 60. Now, we just got one of them. Can we determine this is a maximum or a minimum? It's probably gonna be a max, but just so we can, reflect on this a little bit and just do it. If 60 is here, we're gonna test on each side, say 50 and 70. Fine, let's pick 0, but like, I wouldn't pick 0, but let's pick 0. Let's pick 50, bro. 60 minus 50 is 10, so it's positive here. And then 60 minus 70 is negative 10, so it's negative here. So it's increasing to the left of 60, decreasing to the right of 60. So this has to be a maximum. So now all we do is we substitute 60 into like here. Yeah, or you could put it right here. Right? You can put it in either one. Right? You could put it in this one or the other one. Let's put it in this one. Half times 60 times 120 minus 60. So that's 30 times 60. So the maximum area is 1800. And you're done. Well, not area. Yeah. Is it area? It's area. It's A. And that's it. I could. Are any of your teachers using this as the Microsoft Surface?
That's not
I
like
have an
that.
application right now, and I can promise you things.
I know, but have they? Why not? But they're gonna think I'm conceited and arrogant.
Mister, you should get a commission link, so every time you send a Surface Pro, go like get some money.
Man, I should get money. I'm gonna buy a Surface Pro 9, but I'm kind of want to wait till the next generation. Besides, I'm putting together another computer, and I will put that engine together. A Ford 351, a V8. I have a balanced reciprocating assembly. I have the block finished. I just need to clean the block and start assembling it and make sure my clearances are good, gap the rings. And then I'll have to order the camshaft and I'll put the heads together, but I gotta get the camshaft in and the oil pump, the timing chain. I gotta paint the engine block. I gotta paint the oil pan. I gotta get the gasket sets. I wonder if this guy got me the gaskets. No, he didn't get me gaskets.
Are you building it like in your house?
Yeah, my house. I wonder if he charged me for gaskets. If he charged me for gaskets, I need my gaskets. Anyways. Let's continue. All right. We have about 15 minutes, I guess, to do the next question. So here's what I want to do. I'm going to pause the recording. And I want you to see if you could do number 13. 13. So let's do that. I'm gonna pause the record. Zoom recording. All right, it says there, number 14, an open rectangular box is to be made with a square base. And its capacity is to be 4,000 centimeters cubed. So that's a volume. Find the length of the side of the base when the amount of material used to make the box is as small as possible. So let's go through the question carefully. And I don't know why this is stuck here. Your screen share, fine. I'm screen sharing. But why is it coming up here? Give me 1 second, guys, because my screen share. Oh, there we go. So an open rectangular box is made with a square base. So let me go ahead and draw the square base here. Let me use purple. So here's a base. I'm gonna say it's a square. So that's my square base when it draws itself out there on the board. Okay. So that's the square base. Now it's a box, so the box obviously has this here that we create. All right, so there we go. It says here that the capacity is 4,000 centimeters cubed. So its capacity is what? Is it volume? Volume is 4,000 centimeters cubed. Now it says find the length of the side of the base. So find the length of the sides. I'll call them S. I guess so, yeah. I guess so. So it's a side. It says find the length of the sides of the base when the amount of material used to make the box is as small as possible. Okay. So let's talk about the problem. Recording. So let's take a look at the start of the question. We have a box. All right. Its volume is limited to 4,000 centimeters cubed. So what I did is I drew the box. S times S is the area of the base. And I call this height here X. Now, in the question, it says an open rectangular box is made with a square base and its capacity is to be 4,000 centimeters cubed. So that's what I wrote here. Okay. Now, it says here, find the length of the side of the base when the amount of material used to make the box is as small as possible. So what we started doing is we said the volume has to equal S times X. So that's the area of the base times the height, X. And so that means 4,000 equals S squared times X. So we're here. Okay? Now, this last part here, ignore flaps, is something that I didn't care to consider. Well, I haven't checked it. You want me to check? Darn it. Okay, give me a second. Let's check the answer key. Only be careful. You know what? I gave away my stats book. Does anybody have a stats book with them?
One of the chair.
Yeah, but it has to be this one. It has to be. This is on page 110, right? What problem was it? Number? Let's see. The answer is 20.
It is funny, but you are paying attention to me. Flap. Maybe that is not flap, but-
So this question was number 14, and the answer is 20. So let's return to this so that everybody. Here's the thing. When it said. So, yes. Yeah, be careful. So here's the thing, when we said ignore the flaps. I'm not sure what they mean by that.
Flaps that close the bar,
I'm not sure.
like the box open and then you have like four flaps that close it.
I know, I just don't, again, this is a question of what ignore flaps means. But you cannot do this problem if you did not take this into consideration. Because the material that makes the box, we call it surface area. The surface area, you understood that part. It was S squared plus the flaps. That's what I think of flaps. I'm thinking that this is the flap. This is the part that makes the walls of the box, right? So, do you see how I got that though? Do you see how I got that area? The area that makes up the box, when I open it up, is S times S plus 4 of these guys, which are each S times X. So that allows me to write it like that. S squared plus 4SX. But then, since I want to find out, I want to find out the surface area, the minimum surface area in this case. I have to go ahead and take the derivative of S with respect to S because they want it in for S. They want you to figure out the size, not the X. If it would have asked me for the X height, then I would have figured out the X. But then what I do is I say, hey, X has to be 4,000 divided by S squared. I get it from here. So that allows me this substitution right there of 4,000 divided by S squared. Then all it is from there is some algebraic manipulation, right? Which allows me to write like this. Notice that one of the S's is canceled. So I'm just left with an S in the denominator. And I write S squared plus 16,000 S to the negative 1. And then I take the derivative of that. When I take the derivative of that, I set it equal to 0. And then I solve for it. And it gives me S is 20. Right? Now here's the catch. I don't know if the S is a 20 is a minimum or maximum, but if I wanted to check, all I gotta do is I do my little number line here. 20's in the middle. 20's in the middle. And then you have let's say, I don't know, pick 19, pick 21. and check for signs. So we go here to the derivative. So here's the derivative. We go there. 2 times 19 minus 16,000 divided by 19 squared. That's gonna be 38 divided by, well, 16,000 divided by 19 squared is equal to 44. So 38 minus 44.3, is that positive or negative? Is 38 minus 44.3 positive or negative? Negative. So now we check the other side. 3 times 21 minus 16,000 divided by 21 squared. So 3 times 21 is 63 minus, what is it? Oh, 2. I don't know why. Because I saw the 3 up top. 42 now. 42. So 42, let me go ahead and write this a little bit lower. I have space. 42 minus, what's 16,000? 16,000 divided by 21 squared. That's 36.3. Is that going to be positive or negative? Positive. So that means decreasing on the left, increasing on the right. So obviously 20 there is a minimum. This is a min. So in order to get to use the minimal amount of material to have 4,000 of volume, we need to pick a base, a side of the base of the square base to be 20. As a consequence, you can also figure out what is going to be your height of your box. Because remember, we said that the height of the box, x, must equal 4,000 divided by s squared. And we've just determined that 4,000 divided by, and s was 20, so 20 squared. So it's 4,000 divided by 40. So now we have basically what? By 400, sorry. We have what? 10? So that means that your box should have dimensions of 20 by 20 by 10. And this box will have a volume of 4,000 and its surface area would be at a minimum. We use the minimum amount of material, the minimum amount of dimensions needed to acquire that necessary volume. This is an optimization problem, guys. Make sense? Do you feel better? Do you guys want to hear what I'm thinking? Yes.
The box that on the shelf, there's flaps.
Yeah, okay. This is what they mean by flaps. Guys, money, chocolate, look like a.
The sweet of your life, guys. You want some chocolate? Thank you.
Have a great day. All right. My problem is I see so many faces here, some people sleeping, some people completely disinterested. I'm talking to myself, I'm thinking to myself, why can't they not be like me? I look like I'm interested in a topic matter. I'm trying to teach people who don't want to learn. This is like golden stuff that you should learn. It's the God's talking to you. But you wouldn't know what God is if he stood in front of you. Education is wasted on the youth. Have you heard of that? All right, can I erase this? Wait, yes, of course. Tell me where? Yes, of course. Here we go. Only if you are careful. So don't you think that question was pretty cool? Yes. Yes, I will zoom out. Let Desiree finish her stuff. So Jan asked me, what can I do? What can I do to catch up? I'm like, what? There's just pick up chapter 8 when we start chapter 8. Because it's a lot of stuff. It's a lot of stuff. If only I can. Here you go, Jan. Here, this is for you. Wait, out a little bit more. Out a little bit more. Guys, all you gotta do is develop love for the subject. Even if you're not good at it, if you start seeing yourself as capable of doing it and you put in the time, you will be able to do it. And if you do it on a consistent enough basis within a very short period of time, within a year or two, you'll be drastically different. May I borrar esto? Yay. Now, guys, you should talk to your teachers about using this tool. You know? Don't you think it's a good tool? I see. So they don't have real topic matters, do they? They don't have to write. But you don't think this is cool, like making a recording? Like you could do the same thing. You could take a Surface, attach a camera to it, and do your lecture. And do a Zoom meeting. Oh my God. Oh my. It did. It turned out. Yes. Yes. All right, guys. Do you want to try one more question? I know you don't want to, but let's just pretend you said yes. It says an open, guys, I get paid whether I teach you or not. Now, I shouldn't say this in a recording. What I mean by that is I get paid whichever method I choose to teach you, whether I'm trying to be effective or not. Now, whether I'm effective or not, that's a whole nother story. You know, you might say, it doesn't matter, you tried, but we didn't learn anything. And I say to myself, well, did you try when you got home on a consistent basis? And the answer is probably no. And then you play Call of Duty and you're not even good at Call of Duty. All right. An open cylindrical waste paper bin. Wait, I don't want to do that one. I want to do number 6. Well, let's just do 15. An open cylindrical waste paper bin of radius R and capacity V is to have a surface area of 5,000 centimeters cubed. Okay. So let's do that. Let's draw it out. Sophia, do you want to draw it out on my surface, bro? Can you draw a cylinder?
Do you want to see how I do the square?
Oh, that's not very good.
It's horrible.
Okay, look, here's how I would do it. Let me teach you. I would make a slanted circle. I'll put a line here, and I will put another circle at the bottom. That's my cylinder.
Okay, I think mine could come out better.
The bottom is mad.
Okay, wait, I'll fix it. No, I don't like it either. It doesn't matter. Who cares? But here's the catch. Where's the radius? Here is the radius. By the way, is it an open cylindrical wastebasket? It is, and it's cylindrical. It's not like that one, which is not cylindrical. That's like, it's like a cone that they cut a piece off of it. Because if you keep on going down, it would meet at a certain point. That one's not a cylinder. That's more complicated design. And it has, what else? It has a volume. So the volume, what's the volume of this cylinder supposed to be? What's the volume? We don't know. But it has a surface area, how much? What's the surface area? What's the surface area? 5,000. Now, it's telling us right now, hey, show that V equals 1/2 R times 5,000 minus pi R squared. Show that. Yes, this is like the cheap problem, but let me sort you out. Do you know what the volume of a cylinder is? What's the formula? Pi R squared times the height. Now, do you know the surface area of this open cylinder? Okay, the surface area, I don't have it memorized, but I will tell you this. Imagine you cut the cylinder down the middle, you remove the bottom, so the bottom is like this, and you cut it down the middle and you rolled it out. So if you rolled it out, it would be a rectangle. You rolled out the rectangle. You know it has a height, right? And you know that this guy here would be the circumference of the circle. Do you get that? So you saw what I did there? Because we want to figure out the surface area of this cylinder wastebasket, right? So we know that the bottom surface area is just going to be the area of that circle. Right? The area of the bottom of this of the basket is just going to be that circle. So this is going to be area equals pi R squared. Now, when I get the scissors and I cut the side and I unroll it, the height is still the height. So this height here is whatever it is. But when I unfurled it, it's almost as if, imagine it would be the same length as if I cut that circle and extended it. Does that make sense? If I go like this, I have made a cylinder. You see it? This is a circle. The circumference of that circle is 2 pi R. This length here will be 2 pi R. When I go like that, the length here is the circumference of that circle. The height is still the same. So now I know that this circumference, C, is going to be equal to 2 pi R. So the area has to be 2 pi R times H. So the total surface area is going to be 2 pi R H plus pi R squared. It's going to happen. I know it is. I feel it. I feel it. There, it happened. It happened. Look. The gods have spoken. Like magic. Look. So do you see it? The surface area equals 2 pi RH plus pi R squared. Agreed? Now, yeah. Oh, wait, I've gotten a little bit, I've pushed forward with the problem without even solving part A. But let's take a look at part A. Part A says, show that the volume is half R times 5,000 pi R squared. So our problem here is we got to replace the H with something, right? What is the surface area equal to? So we can write 5,000 equals 2 pi RH plus pi R squared. Do you agree or disagree? Now, if only I can replace the H here, if I can replace that H with everything R, then I'd be in a good spot to show that the volume is equal to half R times 5,000 minus pi R squared. So I would go ahead and do that. So right here, I would just rewrite this as 2 pi RH equals 5,000 minus pi R squared. And then that's going to be H equals 5,000 divided by 2 pi RH minus, sorry, it should be 2 pi R, my bad, minus pi R squared divided by 2 pi R. So we have H equals, you're out? Oh,
No, not in the school. It just arrived. I gotta pick up this weekend.
congrats. You guys a C8. Yeah, we'll leave you guys. Well, when I bought my Corvette, and I bought it, he drove my Corvette. This was like 2008, 2009. And I let him drive. I'm like, go as fast as you can. He's like, yeah, I like it. But then now he has his Corvette, so I'm gonna drive it. Plus, I let him drive my Mustang too. Yeah, I let him drive my Mustang too. My project Mustang, yes. No, I sold it. When my wife was pregnant with Marilyn, I'm like, oh man. I was just thinking to myself, like, I don't that the car is doing nothing for me. So I had to get rid of it. Anyways, 5,000 divided by 2 pi R. Well, that's I will have again, but I don't know. 2,500 divided by pi R. So does that make sense what I did there? Minus the pi's cancel there. One of the R's cancel, and you're left with R squared divided by 2. Sorry, R divided by 2. Right? And so now, do you want me to combine that or leave that alone? Let's combine it. We have 5,000 minus pi R squared divided by 2 pi R is your height. So now I'm going to go ahead and substitute that into there. So the volume equals pi R squared times 5,000 minus pi R squared divided by 2 pi R. And so we have the volume equals I'm gonna factor out a half pi. So if I factor out half pi R, so pi R squared divided by 2 pi R times 5,000 minus pi R squared, and then these cancel, and I'm left with half R times 5,000 minus pi R squared, and that is, we've just shown that the volume equals that. Volume equals that. You saw that? But now I can go ahead and solve the second part. It says calculate the maximum possible capacity of the bin. So what do you have to do now? You have to take the derivative. Okay.
of V with respect to R, it's gonna be a maximum, hopefully. And then that R will give you that value, so you can substitute it into the equation to get the maximum volume. With a limiting factor of a surface area of no more than 5,000. So to wrap up that question, we would do the following, we would say, hey, V equals 2,500 R, and I'm gonna distribute minus half pi R to the third. And so dV dr is going to be equal to 2,500 minus 3/2 pi R squared. And so when I set that equal to 0, you have that basically 3/2 pi R squared equals to 2,500. And then you have that R squared equals to 5,000 divided by 3 pi. And then you have that R must equal the plus or minus the square root of 5,000 divided by 3 pi. And so therefore, I can already tell you that I'm going to choose the positive because the negative has no meaning here. And so this will be a situation where R is probably maxed out. Just to get, let's get a an approximation here. 5,000 divided by parentheses 3 times, where's pi here? Pi. No, not that. Pi. Dun, dun. So this is approximately 530. What? That feels weird to me, guys. Oh yeah, but then I have to square root it, right? So radius is 23.03 approximately. So approximately this. When it loads eventually. Why is it so slow? Okay, come on, computer. Quick. No, it's about 15 seconds behind. And so that is the radius, but we got to find the volume. So we can go back all the way up here and substitute into this formula, which I will probably put it right here. I'll put volume equals half times the square root of 5,000 divided by 3 pi times 5,000 minus pi times the square root of 5,000 divided by 3 pi squared, and that's volume equals half times the square root of 5,000 divided by 3 pi times 5,000 minus 5,000 divided by 3 pi because when I squared it, the radical disappeared, so this cancels out. And then so you have half times the square root of 5,000 divided by 3 pi times 5,000 minus 5,000 divided by 3. So that's volume equals half times the square root of 5,000 divided by 3 pi. That's 15,000 minus 5,000 divided by 3. So volume equals half times the square root of 5,000 divided by 3 pi times 10,000 divided by 3. So I'm going to go ahead. I kept that in memory. I'm going to go ahead and multiply this by 10,000. Divide that by 3. Divided by 2. The volume says it's 38,000. 38,388. Bye. Have a great weekend. Point 24. And then just to make sure I did everything right, let's take a look at the answer. Bye-bye.
That's it.
Yes. What happened? Take care, 38,400, we're good, the answer's correct. Yeah. Take care, take care. Feel better, Elionen. So I'm gonna stop this. Hi, how are you doing?